Okay, good morning class. Alright, so today we will continue with our lessons, alright, with the characteristic of image formed by concave lens, right? So before we move to the concave lens, right, so let's see the convex lens first, right? We just give a review. Okay, a quick review for the convex lens. So this is when the object distance, okay, is more than 2f. Okay, so means the object is further than 2f, right? So this is 2f. Okay, the distance 2f is from here to here, and while the object is here to here. So you can see the object is much further. Okay, and this is the case number 2 when the object is same as the 2f. Okay, so you got the real, inverted, and same size image. Okay, and this is the case number 3 when the object is between f and 2f. Okay, and this is case number 4 when the object is same as the focal length. So this one you will get visual, magnified, and upright, and also the image is at the infinity. Okay, and the case number 5, the last one, is when the object distance, okay, is less than the focal length. Okay, so this is the object distance from here to here. Okay, while the focal length is here to here. So means the object distance is shorter than the focal length. So you will get the image visual, upright, and also magnified. Okay, so this is the summarize. Okay, for the each object distance. Okay, what is the characteristic of image that will be formed? Okay, all right. So now we move on to the next one. Okay, that is a concave lens. All right. So for the concave lens, you already know concave lens is a diverging lens. Okay, so means when all the light pass through the concave lens, okay, it will be diverged, right? So this is how you want to draw. Okay, for the concave lens, okay, just draw a straight line. Okay, and the line there will be diverged here. Okay, the light ray will be diverged. Okay, and after that you have to make the line longer, then it will pass through the f, and then you need to make it, you will go straight line like that, and also the next one must pass through the optical center. Okay, but as I told you on Monday, right, I will just use the first rule and the third rule. This means I will just use this, okay, this light ray, and also this one. Okay, so I just use two, so then you can get the intersection. So that's the image, right? So I will show you how to draw. Right, so the first one, what you have to do, okay, a moment. Okay, so from here you go straight, okay, to the optical center here, right? So I change the color first. Okay, and then you already know this is the diverging lens, right? So means all the light ray will be diverged. So then this one, it will be diverged. Okay, then after that it will pass through the F. Okay, just make the line longer and pass through the F here like that. Okay, and the next one, okay, it pass through the center here. Okay, like this. Alright, so you can see there is an intersection right here. Okay, so this will be the image, right? So this is the image. Okay, so this will be the image. So what's the characteristic of the image? So the characteristic is a visual, right? It's a visual, okay, and upright. Okay, and another one, it should be diminished. Okay, the size of the image, okay, is smaller than the object. Okay, Alright, so that's the characteristic of the image that formed by the concave lens. Okay, so as you can see just now when we do a review, a quick review for the convex lens. So there, the convex lens has 5 cases, right? So means it depends on the object distance. So every object distance that will produce different characteristic of image. Okay, so for convex lens, they have to depend to the object distance, and every object distance, okay, will produce the different characteristic of image. Okay, let's say for u is smaller than f, okay, the object distance is smaller than f, you will produce the visual upright and magnified image. Okay, so if the image is u is equals to 2f, the object the image will be inverted, same size, and also real. So every object distance, okay, they have a different characteristic of image. Okay, that is for the convex lens. But for the concave lens, it doesn't matter where is the object. Okay, whether is u is equals to f, u between f or 2f, u is bigger than 2f. Okay, so it doesn't matter where. Okay, the characteristic of the image, okay, will always be same. Okay, and also the drawing also is same. Okay, so this one is where u is bigger than 2f, right? This one is u is bigger than 2f, so you will get this kind of image. Okay, so what happened, okay, so as a proof, what happened if u is between f and 2f? Okay, so what will the image, okay, what is the characteristic of the image that will be formed? So again, okay, so we use the rule number 1 and rule number 3, okay, to draw the ray diagram. The first one is from here to here, okay, and the second one, okay, it will diverge because this one is a convex. Okay, then you make it longer until it pass through the f. Okay, then after that you pass through the optical center here. Okay, then we got the image. Okay, so this is the image here, right? So you can see it's still same, the characteristic, right? It's still diminished. Okay, it's still smaller than the object. Okay, and it's still visual. Okay, visual, and another one is still upright, right? Okay, so this one is proof that for the concave lens, it doesn't matter where is your object, the characteristic image will always be the same, and the drawing also, the way to draw also is same. Okay, so that is the concave lens. Okay, and this is the summarize. Okay, so the next one, okay, the next one what we see is the magnification, right? So how you want to find the linear magnification? So we use the formula, okay, where the formula is v divided by u. So I think you already remember what is v, okay? So v is actually, okay, from here to here, means from the image to the optical center here, right? So from here to here is v, okay? And what is u? U is from here to here, okay, from the object to the optical center. So that is u. Okay, so let's say this one 3 unit and this one is, let's say 3, 6, 9, 12. So let's say 12. So v divided by u means 3 divided by 12, you get 1 over 4. Okay, 1 over 4 or 0.25, right? So that will be the linear magnification. Okay, so you just divide the distance, image distance, divide by the object distance. Okay, so that's the how you want to find the linear magnification. Okay, so this one for the tutorial. Okay, I just want you to answer first. Okay, then when the school open, we will discuss this one. Okay, and I want to move on to the next one. Okay, there is a thin lens equation. Okay, so this is the experiment. Okay, but I'm not sure we can done the experiment because this experiment need to be done in a dark room. Okay, so The first inference, the inference for this experiment is we need to show that the image distance, okay, is influenced by the object distance. Okay, so means whether if you keep increase the object distance, what will happen to the image distance? Okay, whether it will decrease or it will increase. Alright, so the aim for the experiment to study the relationship between the object distance u, okay, and image distance v for convex lens. Alright, so basically I will show you a video, okay, how does this experiment can be conducted in the lab, right? Okay, so this is the experiment setup. You need a power supply here, okay, and you need a bulb, okay, and you put inside the box, okay, and you can you as you notice here there is a triangle here, so this triangle will be the object, okay, and also within the triangle they got the wire, they put a wire there, okay, so later we will see, okay, what type of image that will be formed. Okay, so the triangle here will be acting as the object, okay, and this is the lens, okay, we use a convex lens, and this one is the screen, okay, so means of the image will be formed, okay, on top of this cardboard. Okay, now when we conduct the experiment, all right, so before that, okay, from the lens to the triangle, this is the object distance, right? From the triangle, I already told you just now, the triangle acts as the object. So from the triangle to the lens, this is the object distance. Okay. So from the lens to the screen where the image is being formed, okay, on the screen, so this one is V. Okay, so this one is V and this one is U. Okay, from the object to the lens is U, from the lens to the screen where the image, okay, being formed in this on top of the screen, so this one is V. Okay, so started with let's say we start with 10 cm. Okay, so let's say this is 10 cm, the U is 10 cm, then we have to adjust, okay, we have to adjust the screen, okay, then after you switch on the power supply, okay, and then the triangle will be formed, right, okay, on top of the screen here, okay, at first there might be blur like that, okay, so you need to adjust the screen, okay, back and forth until it can produce the sharp, okay, the sharp and bright image, so like this. So this is actually the coil that I mentioned just now, okay, that you put between the triangle, okay, you put within the triangle here, so this is the object, so you need to make sure that the line is clear, so you just adjust the screen. Okay, now the line is already clear, so the next one what you have to do, okay, you have to read the measurement, so you just make it back and forth like that, okay, until you can see, yeah, so now it become clear, right? So then you stop. So once you already stop, you already make sure that the image is clear, so you just measure from here to here is how many cm, right? It's how many cm. Okay, and from here to here we already decide, right? Let's say just now I take this one is 10 cm, so this one, okay, you just measure when the image is formed is here, okay, so you got the V value, so now you already have U and you already have V. Okay, so let's see the table. Okay, so then you change lah, okay, because now I start with 10, right, so you increase 15, 20, 25. Okay, the object distance you keep increase 10, 15, 20, 25 like that. Okay, okay, and then after that you read the V, okay, it's the V value there. So once we already finish the experiment, okay, as you can see here, when you increase the object distance, the image distance is decreased, right? So what's the relationship here? Is the inversely proportional. So when the U increase, when the object distance increase, the image distance will be decreased. Okay, so that's the relationship. Okay, now we go back to the PowerPoint. Right. Okay, we already done until here. So this is the experiment that I just explained to you just now. Okay, so this one should be a manipulated variable. This one should be responding. So this one maybe you can decide 10 cm. Okay, then you just move the screen. Okay, when it already form the clear image, then you stop, then you read the value of V here, then you change to 10 cm, then again you move it back and forth until it produce a clear image, then you read again. Okay, so until you got at least 5 reading. Okay, so this is the reading and this is a graph. Okay, so the graph we have to plot the 1 over V against 1 over U. Okay, and you need to find the y-intercept. So this is the y-intercept. That means 0.1. Okay, so the intercept here is 0.1. Okay, and the gradient. Okay, for the gradient, okay, this is the formula. Okay, so as you can see here, you need two coordinates. So I just take this one. So this one is 0.1, right? And this one I take this is another coordinate. Okay, so wait for a moment. Cannot see clearly the x-axis here. So 0.05. Okay, so the next coordinate is 0.045. Wait. 0.0545 wait, I take not the 0.055. Okay, and 0.045. Right. Okay, so for this coordinate is 0. Okay, 0.055, and another one is 0.045. Okay, so that's the coordinate. Then I just substitute, okay, the unit. Okay, so let's say I put this one as xy, y1, and this one is x2, y2. Okay, so 0.1 minus with y2 minus y1, right? Based from the formula, means 0.1 minus with 0.045. Okay, then you divide with 0.0, wait, 0 minus 0.055. Okay, so the first one is 0.1 minus 0.045. Okay, y2 minus y1, and after that for x2 is 0 minus 0.055. So what you will get here, you will get -1. So that's the gradient. Okay, so I hope you still remember, okay, when I asked you to remember about the precaution for the experiment. So I said you just use this one, make sure your eyes is perpendicular to the scale reading of, okay, so of the measuring instrument. So for the measuring instrument, you need to see what experiment and what the measuring tools that being used. Okay, so let's say ruler, then you have to replace it with ruler. So let's say this one they use a ruler, so make sure your eyes is perpendicular to the scale reading of ruler to avoid parallax error. Okay, that's the first one. So but in the light experiment, there's another precaution that you can take. That is, we have to do the experiment in the dark room. So that is the another precaution. So the first precaution, okay, the one that I told you just now, make sure your eyes is perpendicular to the scale reading. So that one is suitable for all the experiment. Okay, let's say for the light, let's say they give you, they want two precaution, and maybe the question is about the light experiment. So you can take this one, okay, do the experiment in the dark room as your second precaution. Okay, don't take the repeat the experiment 3 times and find the average. Okay, so don't use that one. Okay, all right. So we move on to the next one. Okay, so deduce how the value of the intercept relate the focal length of the lens. So actually C, okay, the intersection of the y-axis is actually equals to 1 over f. Okay, so your C just now is 0.1, right? Okay, so 1 over f. So if I want to find f, so my f is 10 cm. Okay, so mean my focal length is 10 cm. So then you have to write down. Okay, so this one is for number 3. Okay, we already find the focal length. Okay, and number 4, they ask you to find the equation. Write down an equation to relate between the object distance, image distance, and also the focal length. So again, this is the straight line. So I think you already know the equation for the straight line is y is equals to mx plus c. So your y is 1 over v. So I just replace it with 1 over v. While your m is the gradient, we already calculate just now, right? We got negative 1. And your x-axis is 1 over u. Okay, and again your y-intercept is 1 over f, right? So I just replace it with 1 over f here. So we can form the lens equation here, okay, by put 1 over f. Okay, so for this one is actually negative 1 over u, right? Because negative 1 multiplied by 1 over u, we get negative 1 over u. So never mind, just put negative 1 over u here. Okay, no, because this one already changed to here, right? So it become positive. Okay, and plus 1 over v. So 1 over f is 1 over u plus 1 over v. Okay, so this one when negative, when I change here, it will become positive, right? So this is the equation that you will get. 1 over f is equals to 1 over u plus 1 over v. So this one we call it as the lens equation. Okay, lens equation. Okay, so that is the equation that relate the object distance, the image distance, and also the focal length. Okay, so this is the equation. And state the relationship between the object distance and image distance. So this one we already see, right? When you increase the object distance, the image distance will be decreased. So inversely proportional. Okay, so the next one is the lens formula. Okay, we already derived the lens formula just now. Okay, for the u is the object distance, right? So if the object is a real object, the u will be positive value. Okay, but let's say if a negative, okay, it means that the object is a virtual. Okay, the object is virtual, but usually in exam the object is real, not virtual. Okay, so this is the sign, okay, for u if it's a real or virtual object. So the next one is the v. So for the v, you need to see what type of image that been formed. So if the image form is real image, okay, so means your v should be v positive v. Means let's say 5 cm, your image distance is 5 cm, so you should put positive 5 cm like that. Okay, but let's say if your image is virtual, right? So you have to put negative v, so negative 5, right? So we will see the calculation on next class. Okay, and f, okay, for the convex lens is positive, but for the concave lens is a negative. Your f should be negative. Okay, so that is the lens formula. So for this, all the exercise, right? I want you to do the exercise. Okay, then maybe next week on Monday, okay, we will discuss, right? Maybe a few questions. Okay, then the rest you have to do on your own. Then we will discuss when the school open. Then we go to the next subtopic. Okay, so there are 2 more subtopic. Then after that we are finished. Okay, so thank you everyone. So take care. Bye.